Hi, Cliff Brake from Beck Systems. Today I would like to talk about part numbers. Be more efficient, make less mistakes. So there's a lot of problems we run into in managing stuff. We might duplicate information, get the wrong part, make mistakes, get the wrong item. There's a whole host of problems we run into and ways to manage these problems. So internal part numbers is a convention of part numbers that are a way to identify stuff your organization deals with. So this might be components and products, and really all parts of the organization deal with it. From the engineering side, where you're building and specifying, to purchasing, manufacturing. Customers need to order the right stuff. They need to be able to report to support and service what they have. And sales, we need to sell the right stuff. Anyway, it's important that we be able to identify properly what we're building, producing, and selling. IPNs are for humans, not for machines. So today there may be a thought that, computers can do everything. Our automated manufacturing, we don't need to have humans dealing with parts. And for printed circuit board assembly, that's probably true, where you have a pick and place machine assembling the board. Humans are not touching these parts. It's not a big deal. But somebody's got to stick that printed circuit board in an assembly, wire up some fans, stick it in a box, put the correct documentation in there. When somebody wants to sell the device, they need to make sure they specify the right one to get sold. Especially for product lines where there's lots of variations, lots of versions. Pretty soon humans need to interact at a lot of different points through the life cycle of this product. So IPNs are for humans, so we want to focus on making something that's useful for a human and hard to make mistakes. So I did a little research, who uses intelligent part numbers. There's kind of debate in our industry, or maybe just more of some companies use unstructured part numbers that are just simply a number. Some people put some structure into their part numbers. But there's a couple companies that stood out to me that use intelligent part numbers. Toyota, apparently you can kind of tell where on the car a part belongs just from its part number. McMaster Car, they sell they very efficiently sell lots of mechanical parts. So they might have a series of screws, and the length might be, they encode the length as a variation with a common base part number. BMW has intelligent part numbers. So let's just go through a little exercise. Let's say you're out at a shelf picking a part, and you need to get the right one. Which one of these three part numbers is easiest for you to visually match? And I'll leave you to answer that. So there's kind of a range of ways to do part numbers. The top one I'll call unstructured. That's just simply a number. The middle one is semi-structured, and here we've broken it down into 3 sections, and we're going to keep it reasonably short. And the last one is fully structured, where we just attempt to encode every bit of information about the part into a single string, and we'll call that the fully structured. I think for humans, the semi-structured is the winner because it's easy to recognize, it's easy to process in the field, it's easy to remember for common parts, and it's easy to organize. So here's one way to do this. There's lots of different ways, and every business is probably different, so I don't claim that this is universally best, but it seems to make sense. So the first 3 letters are a category. It identifies a major category, and we're talking about maybe a couple dozen categories. We're not talking thousands of categories, because the goal with this is to be able to quickly identify where something should go or where to look for something. And for this, there has to be a reasonably small number of categories. But having these categories allows us to really do a lot of organization whether it's physical organization in the warehouse or mental organization, like what library do I put this CAD part in. It helps a lot. So the middle section is an incrementing sequential number, and this gives us the flexibility to have lots of parts, without being constrained by a certain number of fields. The last part is a variation or variant, and we use this to encode version or a variant, and we'll talk more about that. Consistency is important because and I'm talking about length and format, you know it when you see it. So if a customer sends you a part number from a device they have, and to support, you can quickly look at it and say, yep, that's the part number, or no, that's something else. You need to get this number from the part or from the product. So it's likewise if you're in a dark, dimly lit room and you're looking at the label on the back of a piece of equipment and there's a bunch of information, you can quickly identify the part number and extract that information without having to think too hard about which one is the part number. Everything should have a part number, from a printed circuit board to a resistor to documentation to software, work instructions, and also on your website. Every item you sell should have a product number that's easily identified, and anybody in the organization knows how to deal with that number. One reason it's important for everything to have a consistent part number is today's product may be tomorrow's component. So let's say you're building a sensor device today and selling that as a product, and tomorrow you might be embedding that sensor device into a larger product. And this is a natural evolution of product development, so having the flexibility to move stuff around at different levels is very, very useful. Conversely, you may be building a product that has a camera module, that's a component today in manufacturing, but tomorrow you may want to sell that component on your website as a replacement part for a product. So again, if your sales and website can use the same product, same IPN as your manufacturing, it's easily to move components back and forth and products as needed. So it's very important to identify versions of things, and that should be quickly identified. So anything that has a version, we put that into the variation field. And there's also variants. So like a resistor, we might have a series of 0805 1% resistors, and we encode the value in the variant field. This allows us to, as design engineers, it's a big help to maintain libraries and avoid duplicate parts if we can group resistors in one base part number and then just the variant changes. It's very difficult to organize things if we don't have some type of structure like this. So we may have cases where we also have a variant and a version. In this case, we can use the first two digits for the variant and the last two for the version. Here's an example of that. So we may have a gateway that has RS-45 or CAN support, and these are two different products. The first one would have an 00 in that field for the RS-45, and the second would have 01 for CAN. And they're both version 2 in this case. We can also have other conventions with our part numbers. Like this product, we're talking about a printed circuit assembly here, and we may want to, this assembly would have a bare PCB, which we call the PCB. And in this case, we're going to use the same sequential number for all of these parts. We have a printed board assembly, printed circuit board, and then the schematic that describes the assembly. Again, if we can use the same kind of make these match, it's very easy to find information and try to keep things sane, but yet have a small enough part number that humans can deal with. So again, here's an example of electrical categories. These have evolved over a number of years that I've been doing electrical design. And the goal here is to have a limited number of categories where we instantly know if we have a new part where it goes. And if we're looking for a part, we can go find it, whether it's in our CAD libraries. So when we set up our CAD libraries, the names of the libraries are exactly what you're seeing here. And if we're in the lab and we're trying to find a part, we can go to our box. They're sorted by IPN. We can quickly find what we're looking for. And likewise on the manufacturing floor or for support. Mechanicals, there's a lot more variation there, so these are just some examples of what I've used in the past, but this needs to be tailored to your organization and what you actually build. Building a car is a much different problem than building an electronic device in an enclosure. Things you produce should also have part numbers, so this is again examples of what we've done in the past for documentation, firmware, software, calibration data, fixtures, so on. So internal part numbers are really part of your IP. It's one thing to design something, it's a whole other thing to manufacture it and manage, support this device, sell it. And IPNs are the language that you describe how things are assembled and how you identify things throughout the product's life cycle. So there's more information on this topic at this link, the github.com/git-plm, and we have more information there as well as some tooling for KiCad. So anyway, appreciate feedback. If you have any thoughts, please let us know, and hope this is helpful. Thanks.